In this video we're going to look at some lift questions, so connected particles. Okay, so again each of these will use F equals ma as your starting point. And again, as I always say, the most important thing is getting the diagram right for these. Okay, so let's look at the question first. Okay, so we've got the person has a mass standing in a lift. The lift has a mass. Okay, so we're going to have to account for both of those when we're looking at this problem. The lift is accelerating upwards. Okay, acceleration is what we're going to have to work out, and we are told the tension. Okay, so let's get the diagram right first. Okay, so diagram, right? Really straightforward. So you're going to have, there's my lift. Oh, the tension going that way. I've got a person in the lift. Okay, so there's my excellent drawing. Little man in a lift. The lift has a mass of 540. That's 540 g. The man, or the person, has a mass of 60 g. And what do we know about the acceleration? It's accelerating upwards, so we know it's accelerating that way. And I should put on that the tension, so that's the tension there, T, and that equals 6,600 newtons. Okay, so I've got my diagram, we're ready to go. Let's do part A. Okay, right, so let's look. Part A. So I'm going to apply F equals ma, Newton's second law, but I'm applying it to the whole thing. So I've got to account for both of these forces and this force on the F side of the equal sign. Okay, so we've got, let's look at it. Acceleration's going that way, tension's going that way. That means they are both positive. So tension, I'm going to have to take away then the weight of the two things in it. Okay, so if I just go back a little bit, I could, actually I'm not going to write tension. I know what tension is. I know tension 6,600. So I'm going to write tension 6,600. Right, the forces that are acting down in the opposite direction to that then are the 540 g, and I've got to take away the 60 g. Okay, because the man, that's all the forces acting downwards, those two. And then what have we got? That equals the mass times acceleration. Remember, it's the mass of all of this. So that's the lift and the man. Okay, so the lift and the man, their two weights, 540 plus 60, so that's 600. And that's multiplied by acceleration, which is what I want to find. Okay, so we've got the difficult bit done. So when you do some of the maths, you get 720 equals 600A. So A equals 1.2 meters per second squared. Don't forget the units. Underline it, make it nice and easy for the examiner to find. Right, part B. Okay, so for part B, we need to find the reaction between the person and the floor of the lift. Okay, so now I'm not interested in the lift. I'm interested in just the man. Sorry, I keep saying man. Person. Okay, so that person's standing there. That person has a reaction, R, acting up off the floor, and their weight is acting down. Okay, which is 60 g. That's supposed to be a 0. Right, I'm only interested in those two forces now. So when I apply F equals ma to the man, okay, the forces that are acting, oh, I didn't mark acceleration. Acceleration's upwards, isn't it? Okay, so remember it's accelerating upwards, and that's important for this bit. Okay, so acceleration's acting upwards, so that means R is acting upwards. Okay, these two things are both acting up, so they're positive. Okay, so I've got R then is the positive one. I've got to take away the 60 g. Okay, that's my forces done, and that equals the mass. I'm only interested in the man in this question, so it's only 60 times acceleration. We've just worked that out. That's times 1.2. So I can rearrange that and get R equals 60 times 1.2 plus 60 g, which is 9.8. So do that in your calculator. You're going to get, hopefully, 660 newtons. Question done. Okay, so the key things to this question, okay, when you're looking at the first bit, okay, you're using this piece of information, okay, that's the tension from holding this up, which is the man and the lift. So you've got to use both over here in the equation. In part B, we're interested in only the man. So I'm looking at the forces acting on the man. He's 60 kilograms, so that's 60 G acting down. The reaction of the floor is R acting up. And then my mass is just 60. Okay, those are the two key points. Okay, in the next question, we've got a parcel on the floor of a lift, which is ascending, so it's going up with an acceleration of 0.8 meters per second squared. The mass of the parcel is 20 kilogram. The mass of the lift is 700 kilograms. Okay, so let's get our diagram right. Let's draw my little diagram. So I've got, there's my lift, there's the cable, so the tension's going that way. I've got the mass of the lift. I have this parcel which is in it, so it also has a mass. I know it's accelerating upwards, so double arrow for acceleration. Acceleration's that way. I got tension there. What's the lift? The lift is 700 G. The parcel is 20, so that's 20 G. There we go, all done. Everything's on there. Okay. So I can see initially, my initial thoughts, tension, same direction as acceleration, so it's going to be my positive. Right, let's do part A. Okay, part A. F equals ma. Okay, we need to find the tension in the cable and the lift. So I'm looking at the lift and whatever's in it. Right, tension's acting up. So tension is going to be positive because it's the same direction as acceleration, which means the 700 G and the 20 G are both going to be negative. So I need to take those away. So minus, I'm going to put both of them together. So I get 720 G. Okay, so all I've done is combine those two forces because I'm taking both of them away. And that equals, remember I'm looking at the mass of the whole thing, so that again is the lift plus the parcel, so that's 720 A. Okay, right. What do we know? We know the acceleration is 0.8, so I can rearrange this to get T equals 720 times 0.8 plus 720 times 9.8, or G. Okay, stick all that into your calculator and you should get 7,632 newtons. Don't forget the units. Underline it so the examiner can find it nice and easily. Right, part B. In part B, we're looking at the reaction of the floor of the lift on the parcel. So I'm only interested in the parcel now. Okay, so I'm going to quickly draw another little diagram. So there's the bottom of my lift. There's my little parcel. Okay, so it's got a weight acting down of 20 G. There's a reaction up, which we'll call R. And I know the acceleration is upwards because it's ascending, and that's 0.8 meters per second. Right, F equals ma for part 2. But remember this time we're only looking at the parcel. Okay, so I can see that reaction and the acceleration are both in the same direction. So reaction is going to be my positive on the force side. So I've got R minus 20. Make that look like a 0. 20G equals 20 times the acceleration. Remember, it's only 20. It's not including the 700 because I'm only looking at the parcel. So it's 20 times acceleration, which is 0.8. Right, do a bit of rearranging. Okay, do the maths, bit of multiplication in your calculator. So you've got 20 times 0.8 plus 20 times 9.8, and you should get 212 newtons. Done. 6 marks. Much wordier question, this one. Okay, so this one's basically we're going to have to use F equals MA 3 times. Okay, so we're going to need 3 little different diagrams. Okay, but let's go through the question first. Okay, so we've got a lift, starts from rest, descends with uniform acceleration. Okay, that's the important bit. Don't worry too much about this starting from rest until it reaches a speed of 9 meters per second, then travels with a constant speed. That's the important bit. Speed's constant. If speed's constant, it's not accelerating, it's not decelerating. For a short time, don't need to know about that, it's brought to rest with a uniform retardation of 2 meters per second. So that means it starts slowing down, so it decelerates. Okay, an object of 6 kilograms is on the floor of the lift. Calculate the magnitude of the reaction of the floor on the object in these 3 stages. Okay, so let's get our 3 diagrams right. So for the first one, okay, I'm going to have my lift. There's my parcel. The parcel is 6g. And this first one, I know that we're accelerating downwards. So it's accelerating that way, okay, and that's 3 meters per second squared. And the reaction will be up. In the middle part of the motion, okay, so there's my little lift. It's a bit wonky. I've still got the 6g force, still got the reaction from the floor, but this time there's no acceleration. So the acceleration equals 0 because it's got a constant velocity. In the third one, there's my parcel. I got the 6g. I've got the reaction, and this time it's slowing down, so it's coming to a stop. So that means it's accelerating that way, and the acceleration is 2 meters. So that is 2 meters per second squared. Okay, got my 3 diagrams, so this hopefully will stop me making any mistakes. Right, so let's have a quick look then at this one. So in this one, acceleration's downwards, my reaction's up, weight of the parcel is down, so this is going to be the positive, so it's going to be this, take away this, same direction as this, so it's positive. So I've got F equals MA, I've got 6g minus R equals 6, it'll look like an equal sign, times 3. Let's rearrange that. So what does the reaction equal? It's going to equal 6g minus, that'll be 18, 3 times 6. So R equals 40. Can't break it 0, let's redo that. 40.8 newtons. First bit done. Okay, second part of the motion. There's no acceleration, so let's apply F equals ma, as we always do. Right, there is no acceleration, so it doesn't matter which way is positive. I'm going to say up's positive, so R is the positive. Take away 6g equals the mass, which is 6, times the acceleration, which is 0. So I get, make that look like a 0, so I get R minus 6g equals nothing. So R equals 6g. Now I would not leave that as my answer. I would not write 6g newtons. Okay, so you need to do 6 times 9.8, and R equals 58.8 newtons. Third answer. Okay, the forces acting upwards will equal forces acting down because there is no acceleration. They will balance. Right, third and final one. You've got F equals ma. So this time, all right, be careful. Right, your reaction is going upwards. So is acceleration. So this time R is positive and the 6g is negative. So you've got R minus 6g equals 6 times 2. R equals 12 plus 6G, which gives R as 70.8 newtons. Done. Okay, just be careful. It's all about getting your directions right. Which way's R? Okay, which way's acceleration? Accelerations always dictates the positive on these two, this side over here. Okay, on the F side. Right, fourth of these questions. We've got to get the diagram right first. Okay, so let's go straight into it. Let's get the diagram done. Right, so we've got a lift. Alright, so tension's going to be acting that way. What do we know about the lift? The lift is 430 kilograms. So that's 430 G. We've got a man in the lift. Okay, so there's our man. Fantastic bit drawn. Should have been an art teacher. We got the man. He's 70 kilograms. Those two numbers make 500. That's nice. Okay. Stand the lift. Tension, we're told, is 480. So the tension up here at the top equals 4,800 newtons. And the lift is descending, so it's going down. Right, so that's my acceleration. And acceleration's a meters per second squared. So part A, we got to find the acceleration of the lift. Right, so F equals ma. Right, so look at our diagram. Acceleration is going down, so that means these are also going the same direction. So these are going to be positive. Okay, so on the F side, when I equate my forces, I'm going to have 430G plus 70G take away 4,800. Right, because I'm looking at the whole lift, so the lift and whatever's in it. So I've got the 430G plus 70G minus 4,800 equals the mass of the lift and everything in it. So that's the man and the weight of the lift. So that's 500. Okay, and that's multiplied by the acceleration. So it's 500A. Right, doesn't look like much before. Okay, so put that together. So you got 500G, take away 4,800. That should get you 100. That equals 500A. So the acceleration equals 0.2 meters per second squared. Done. 3 marks. Okay, underline it. Make sure you're giving your units. Right, part B. What have we got in part B? So in part B, we have to determine the reaction of the floor of the lift on the man. Okay, so I'm just interested in the man, so I'm going to do a really quick little diagram again for this. So there's my lift. There's the man in it. Okay, he is 70G. So we're looking at the forces acting on him. There's a reaction of the floor acting up. It's accelerating downwards, which is really important because that is going to help me get the signs right. F equals ma. So what have we got? Acceleration's acting down, so is his weight. So that means it's 70G minus the reaction. Okay, now the mass, remember it's just the man, so it's 70 times, I've just worked out the acceleration to be 0.2, so 0 times 0.2, so the reaction equals the 70 times 0.2, let's just undo that, that should be negative, and then plus the 70G, did that the wrong way around, but you should get R to equal 672 newtons.